Today we are going to see the topic embedded system design process. Before moving to the topic, let us see what is embedded system. So we all know like embedded system is a computing system in which the processor, the memory unit and the input output peripherals all are integrated in a single electronic system to do a dedicated task for the user. So for designing the embedded system, what are the things we have to look into, or what are the aspects we have to look into? So the first very important thing is the performance of the system. So we need to see whether the system meets up the goal of the users, or for what function we have designed, whether it is meeting that goal or not. The next very important thing is whether it is cost effective. And the next important thing is the power consumption and whether the system is meeting up the deadlines, because today we are designing most of the systems in a real-time mode. So meeting up the deadline is very important thing. So performance, cost, power, whether it is meeting up the deadline or not, and the last is nothing but the upgradability of the system. So these are the very important aspects which we have to look into before we are moving into the design process of the system. So next is why we need this design process, or why we need this design methodology is the three reasons are is first thing is the design methodology will give, or it will act as a scorecard for the designers. So scorecard in the sense, so what are the steps or what are the aspects the designers have been completed, it will act as a scorecard. And the next very important thing is nothing but it is an easier mode to communicate within the design team. It acts as a easier tool, a communication tool to communicate within the design team. And the next thing is we can upgrade the systems using the system new system tools also. So these are the very important objectives or the basic need for the design methodology. So the design methodology which we are going to see is nothing but the top to bottom approach or bottom to top approach. So in that we have various steps which we have to follow before we design an embedded system. So the first step is nothing but the requirement step. So what we require for the system which whatever system we are designing it, so what are the requirements we need in order to meet up the goal. Okay, so the first thing is the requirement stage. So in that requirement we have two kinds of requirements, that is functional requirements and non-functional requirements. So non-functional requirements are nothing but the power consumption of the system, the cost, the size and the weight of the system, all that includes the non-functional case. Functional requirements, it involves these attributes like what is the name of the system, what are the inputs and the outputs of the system, what is the performance of the system, and next what is the functions of the system. So it's like a table, you can just put it as a table and you can list out what the functional requirements are. And the physical size and the weight, physical size and weight, and the power consumption. Power consumption. For example, let us take a GPS moving map system. So the name of the system, we can name it as a GPS moving map system. Then the inputs, if you see for a GPS moving map system, we can give like a power button, and 2 or 3 buttons for just selecting the display aspects. The next is the output. So it is a GPS moving map system, so definitely the display unit is going to be the output device. So you can list out what kind of a display unit you are going to go for, LCD or what LED type, and if it is an LCD type you can also list out the resolution of it. The next is the performance. So performance is, so it is a GPS moving map system. So you need to display the current latitude and longitude of the location. So that is going to be the performance. And next, the current latitude and the longitude has to be displayed or updated every 0.2 seconds or 0.25 seconds. So like that you can fix it out. So the functions are like you can specify give a selectional mode, and 2 to 3 selections you can give the display resolutions, or 5 kind of a user modes you can also use it and design it. And the next is physical size and weight. So size you can always fit as like a palm fit. So palm fit, it has to be handy, right? So the size and the weight, so as it has to be handy, you can specify the size and the weight in ounces or in inches mode, and the power consumption. So at least for 6 to 8 hours you need to have the battery consumption. So based on it you have to list out the power consumption. So like this you need to frame a table and you can list it out. So the first thing is, in the first step in the design methodology becomes the requirement, or it is nothing but the requirement stage. So the next step in the design methodology is the specification. So requirement will list out what you need for designing the system. Specification is quite different. That is, it is going to specify what in detail what the system is going to function, what are the functions of the system in detail it is going to illustrate. So like we have taken the example as a GPS moving map system, right? So for this you are going to get the data from the satellite. So satellite data has to be displayed in your display. So you need to have a renderer which is going to support and display it in a display. So, and also you have to focus on how the resolution is going to be. So all these things has to be specified in the specification aspect. So the next comes the architecture step. So architecture or the functional block diagram will give you a layout of how your system is going to be assembled or how your system is going to be constructed. So for this GPS moving map system we can give the architecture as so first thing, I am going to receive the signal from the satellite. I am going to receive the signal. So I need to have a GPS receiver, receiving unit. Then the signal which is received from the GPS receiver, I am going to give it to my search engine. And the search engine is going to be connected with a database. Okay, and from that search engine I am going to give the signal or connect the signal to a renderer. So renderer is nothing but a tool wherein this signal is going to be converted into an image type which can be displayed in form of a map. So a renderer tool, and from the renderer tool I am going to connect it to a display which is nothing but an LCD display. So with this display I am going to connect all my inputs, output, all these aspects. Okay, so this is a simple block diagram which I am going to which we need it definitely for this GPS moving map system. So like this you can list it out. And the next stage is nothing but listing out what are the components required, what are the hardware components and what are the software components required. So looking into the diagram itself, we can say like I need a receiver. So my search engine has to be connected with definitely a strong memory systems. Then a renderer software tool which is going to convert the signal into this map form of an image. Then the display unit which is going to be nothing but an LCD display connected with the user friendly inputs and the outputs. Okay, so these are the components, the software, hardware, both you are going to list it out. And the last stage you can it is the integration or the system integration stage. So system integration stage is wherein you are going to connect or combine this hardware and the software, you are going to integrate it into a single system, and then you are going to run it out, and also you are going to test it whether your system is performed correctly, or whether it is performing correctly or not. So if it is not functioning properly, you are going to then recorrect it by correcting the bugs, changing out your hardware and the software aspects. Okay, so this system methodology, you call it as actually a top to bottom or bottom to top approach. Top to bottom or bottom to top approach. So the first initial stage where I am designing, this stage, that is right from the requirement to the system integration, it is referred as the top to bottom approach, wherein right from the scratch, from the requirement stage to the integration, I am doing it. Now after I am integrating it and testing it, if I am finding out any bugs, then automatically what I have to do, I have to change out or correct the software program, or if there is if the resolution is not met, I have to change my LCD display. So all these things I have to correct it in the component stage, right? So after that, definitely that is going to be reflected in my architecture stage, then the specification might be changed, and last the requirement also. So from the bottom to top approach, I will always go ahead after designing the system to correct my bugs and to check out whether my system is meeting up the goal or not, whether it is functioning properly or not. So this is the basic methodology which every embedded designers use to design the embedded system. Next, we'll see what are the different types of embedded design methodologies. So in that time, we'll see what is the first type of a model, that is water flow model, and the second type of a design system methodology, the spiral model. Okay. So water flow model, it is always referred as a sequential kind of a model, wherein whatever steps we are going to follow while designing it, it's going to be a sequential stage. So the first thing is the requirement stage. As we saw in the top to bottom approach, we are going to list out what the requirements we need to design the system, and here we don't have the specification step. The requirement and the specification step both are being involved at the first stage itself. And the next is the architecture stage, wherein you are going to lay out what is the blocks or what are the components in your system. Next, the coding, and next at last we are going to test whether how the system is going to work. And the last step in the design methodology is nothing but the maintenance. So at the testing stage only in this model, we are going to test how my system is going to work, and then you're going to find out what the bugs or the errors are, and then you're going to correct it. And what is the new thing step added compared to the top to bottom approach in this water flow model is the maintenance case. So you're going to check how repeatedly you're going to check how you're going to how your system is being working. Okay, so the maintenance step is being added on. So what is the advantages? It's a clear cut kind of design methodology step, wherein it's not a complicated, each and every steps in the next in a sequential manner you're going to follow it. And what is the disadvantage of this model is the errors you're going to the designer can always find out the errors. Advantage of the water flow model is the designer can find the errors only at the last step, that is the testing stage. Only at the testing stage, once they have completed the design, they can find out what the errors are and they can correct it. So the next model is the spiral model, which we refer it as an evolutionary model. Okay, so it is always used for designing the large complex systems. It's an apt model, design model, which a designer can use it for designing the large complex models. So the first initial step is system feasibility. That is, you are going to check out whether the system, how far the system is feasible. And the risk analysis, all the aspects can be done at the initial stage itself. And the next stage is nothing but the specification stage, where you are going to specify what the requirements or what you require to design the system. And the third stage is the prototype design step, and the next is nothing but the system, initial system design. So you are going to test it, how the system is going to work, how it is going to function, all the aspects. The next is the enhanced system. If you are going to want to add on some features or something, at the enhanced system stage we are doing it. So here in this spiral model, each and every step is not going to be a sequential one. At each and every step we are going to find out the analyze how far the risk factor is. You can plan it, and a continuous monitoring can be done in this spiral model. So this model is time consuming, definitely it's going to be a time consuming model, but still it is very useful for the large complex systems and effective too. Okay, so this is the basic two types of the design models I have chosen to explain you, illustrate it. Okay, thank you.